whilst they are doing their daily businesses. All right. And then the same company would have human resource section. So that human resource section is also going to manage the employees' details, their salaries, their payroll, and the benefit that they get. And all this information is supposed to be stored and then managed by the human resource people. Okay. And then also have online retailers. So for sales data noted above plus online order tracking generation of recommendation lists and maintenance of online product evaluation. So sometimes to these companies perform some of the things they do online. So let's take Gigi like this. Gigi, even okay, let's take Gigi, we don't make the payments online. So Jumia payment is done online, tracking is done online, discount is also done online. And all this information needs to be saved somewhere in a database system. So an enterprise also keep track of all the online retails that happen in their shop. Even Melcom does these things too, because they also list some of their products online and people buy it online as well. Did you guys get it? So I want you guys to give me um, a company in Ghana, okay, a company in Ghana that they can use these database systems for their enterprises, and then you explain what they may be using it to do. All right. So anybody to help us with an example in Ghana, and then you just take us through with accounting, what they would use it for, with human resource and all that. Anyone?
Please, the question again.
So the question is that we've known that we can use database systems for an enterprise information, that is keeping accounting records, human resource, that's workers and all that, and then keeping online retail tracking. So I was asking you guys to give me an example of a Ghanaian company, like the way I gave example with the GG and then the rest. And then you take us to what they might use it for in terms of their enterprise.
Oh, okay. Okay, so I want to talk about Tonaton.
Okay.
Yes. So being an e-commerce website, first of all, if you create an account, they will get your details. That is your name, your date of birth, all the relevant information that you are going to provide. And also, provided you are going to sell or either you are going to buy, the item that you post, the details about the item, and then the medium of communication, where if someone want to buy the item that you've posted, how they can contact you. And also, if you've been on the site for a quite long time, all the item that you sold, and then the feedback that those who bought the item gave, they are going to keep all those things so that people that will want to patronize your service will check how your services are doing to be able to decide. So that these are some few things that I can say about it. Hello.
So, all right. Thank you for the input. So we also have banking and finance. Banking and finance. So in banking, we all know that they need to store their client information. So your bank account details. Are you working with maybe a particular company that you are being paid to? Have you taken some loans from the bank? Okay. Many bank transactions that you perform, whether online or face to face in the bank, all these have to be stored in a database somewhere, so that um, Mr. Ahmed, Simba won't come and say that he had 2,000 Ghana cedis in his account, and then when he woke up today, his balance is left with 20 Ghana cedis. and then it wouldn't come and become a problem. And then for finance, it is used for storing information about holdings, sales, purchases of financial instruments such as stocks and bonds, and also storing of real-time market data to enable online trading by customers and automated trading by the firm. So the people that do those online trading thing, as it goes up, data needs to be stored. As the stocks come down to, it needs to also be stored as well. So those that will be buying bonds, those that will be um, obviously doing anything financial, okay, the system need to save it. And then when we talk about schools and universities, even these days, senior high schools have a database for storing all the senior high school uh, students. The same way universities also use these database systems to store information about their students and then workers. Okay. And then we have for airlines too. So if you want to, travel to US, you would obviously have to first of all get your visa application through. So you have to, talk to the US embassy and then go for a visa interview. Now scheduling you and then putting you somewhere, even for the interview itself, that information has to be stored in a database. And then once you buy your airplane tickets, it needs to be stored so that if you are being transited, okay, you wouldn't have to um, lose your data, or there wouldn't be any issues that you bought the tickets, but when you got there, it's like your name is not inside or your name is not in the list. So they use it for all these schedules and reservations, and then they keep all the data in a database somewhere. Okay. Now, have you heard that when planes are made they drive themselves? It's on they call it autopiloting. So that autopiloting, the data and everything about the routes they are taking have been saved in a database somewhere, and then it's just taking the information and then making sure that it goes through to it gets to the last destination. We also have telecommunication. Some calls are recorded. When you receive a call right now, it's even stored on your phone. The same core information is also stored in MTN's or Airtel Tigo or Telecell's database, so that if something happens, you can now go and retrieve the information. Even our Momo transactions that we perform now, all these
Hey, say,
details, yes.
if if all these things are being recorded, then they are listening to the things. So,
Oh, so there were
because the
instances,
way people communicate, they
there were instances where calls were being tracked. I think US, I don't know whether it's true or not, but they tracked Osama bin Laden's his calls, and then they got to know where he is, and then they tracked him down and killed him. You get it? So some of these calls that we do, thinking that it's not being saved somewhere, sometimes it's being saved just for future purposes. Yes, anybody to also give us, areas that we use database systems. I mean, we've talked a lot about these ones. Any areas? These are just the general areas that we know, but I know there are a lot of areas that databases are being used. Anybody? Anyone? Mr. Moses?
Sir,
Yeah,
sir,
go ahead.
sir, please, how about our hospital, like health institutions as well?
Yes, yes.
We
So,
use NHI a card and hello.
yeah, we are listening.
Yeah, so before the card is given,
Hmm.
you would have to provide details and it will be used for the card so that the next time you go there, the moment you use the card, all
Mm-hmm.
details about you would be given.
Yeah.
And they even go to the extent of using some of these cards for transactions, as in paying making payments for services rendered and stuff like that.
Yeah. Yes. Anybody else? Samuel.
Yes, sir.
So please,
The
what about airports and schools, especially tertiary institutions and airports, where if you want to travel, a passport will be given, which contains your details, and the details will be stored on a database, so that anytime that there's issue, they will retrieve it from the database and know where you are. What about that one? Taking schools also as an example, sometimes UCC, for instance, your details are being stored,
Mhm.
and in case of payment of school fees or any issue about you, they will just retrieve that information from your database. So what
Yeah.
about these two examples?
Yeah. I mean, we spoke about the airlines, and then we also spoke about the schools, but those are good inputs. So one professor I work with, I remember, told me that when he went to Denmark, they gave him an ID number, just like the way Ghana card number is. So he he took that to a hospital, and when he got there, they told him that he should provide a number. So he provided a number that they gave him, right? And then he was given medications. And then they told him that he should use the same number that they gave him to go to the pharmacy and then use that number to request for the drugs. You see, Ghana, when you go to hospital, right? They write the drugs on paper for you. And then you take the paper to any pharmacy, or you either buy it or you go to the pharmacy and then they will dispense the drugs for you. But in this case, they didn't give him any form of paper. He just walked straight to the pharmacy, and then they asked him of his ID number, and then he just mentioned it to them, and then they started giving him the medication, and then they printed the medication that the doctor gave. So, like, you see how these systems outside are working. Just one
Yeah,
ID, like your Ghana card ID, and then you can use it to access everything. So in a hospital system like this, imagine if our Ghana card system is integrated to um, the health system, right? It means that since the day that you got your ID, the hospital would have your history, and then the medicines you've taken, your allergies and everything, which is also going to help us and then keep us alive for a longer periods of time. In some cases, you enter some
yeah,
hospital
yeah.
and they don't have a photo of you at all, and now they have to now come and start over again, and then do some small consultations to see if maybe you had a problem before. But imagine if that data was available. Maybe that time you went to the northern region and you haven't been there before, but the data is already linked to your Ghana card ID number. Imagine what that one can help, because now you don't have to waste time going through all the consultations, taking out everything. They already have your history. So you can just, work their way around it and diagnose you. So the person that said health, yes, your medical records, the drugs that you've taken over the years. Some of these systems have like the trackings, the Apple Watch tracking your oxygen, tracking your sleep, and all that. They store all this information in a health information system, which is also going to help the doctors make informed decisions on your health, and then be able to diagnose you faster and easier. Unlike the way Ghana will just probe everything and then take everything off before we get to the diagnosis itself. So yes, I like that inputs. Anybody else?
Yes, sir.
Yeah.
So I was going to talk about the hotels.
Okay.
You see, there are some hotels that you can even make bookings online,
Yeah.
and those that you can do mostly when you go, they have a system that they'll take your details, and then whatever you're going to do, your payment, the room that you'll be assigned to, everything. So mostly when there's some kind of either criminal or some kind of incident, they go to their database and then they're able to track that this person came here at this time and the person left. Yes. And also, we can also talk of investigative institutions. So
Okay.
Ghana here, we can talk of the BNI. They have a
Okay.
database that they store information about some cases they are working on for future records. Yeah.
Yeah. That is very, very, very good. So I've had my fair share of the police system for a while. I needed data for, you see, when accidents happen, right? I needed data to create a predictive model to predict whether the accident that happened, the injuries are severe or not. You know, sometimes these SOS people, they'll go to the scene first, either overly prepared or underprepared. So at least if they have an informed decision, an AI system that will tell them that based on the data that we are getting, this accident will have severe injuries. So when you are going, go with a lot of equipment. You understand? But to train these AI systems, you need data. And then we all know that Ghana here, MTTD is responsible for taking all kinds of traffic data and all that. MTTD is supposed to be doing that. Anything vehicular, you go to MTTD. So I went to the CID office, Cantonment Accra, and I told them that I need individual data of accidents that have occurred within 10 years on Accra Kumasi, Accra Cape Coast, and then Kumasi Cape Coast Road, that triangle. And they told me that for them, they don't get the data individually. Like maybe today, 2 p.m., some accident occurred, 3 people suffer some severe injuries. Then they store it. They don't do that. What they do is that Eastern region, number of accidents that occur 20, number of injuries 5. But I don't need that particular data. I need the data where the particular road the accident occurred in. I don't need the whole region being bundled as one. So when I told him, the man was like, he can't get me the data because they don't get the individual data. So I have to go down to the basic level. That is the police stations to go and take the data. Do you guys understand the number of police stations that are from Accra all the way to Kumasi? So imagine if it is 2,000 police stations. I have to go through all these police stations to get the data. Meanwhile, Ghana is supposed to keep data of these accidents so that we can use it to, enhance research. You get it? So I went to one police station as a start to see if I could get some data and then use it. Now this man told me that now that the driver is dead, is it now that he's going to ask the driver's age? Is it now that he's going to ask how many years that he has used his driver's license for? But we all remember that we have Ghana Driver's License Authority, GVLE, and their whole responsibility is to keep track of cars, number plates, and then driving license, how many years people have been holding the driving license for, the educational background and all that. So you see, the country has a lot of resources in terms of data, but storing it has now become a problem. Okay. And then I told him that, okay, fine. I think they always keep data around them. Like when an accident happens, they keep some data. And he told me that the data that they keep, they can't let me access, they can't give it to civilians because they call it a case diary. They don't give it to any civilian to look at it because it's not only accident data that they record inside. They have other cases that they also report. So they can't let me go through all their case diaries. You guys understand what's going on right now? We have the systems, but to be able to keep up with the data has become a problem.
Yes, sir.
So I've had my fair share of the security, but I mean they still keep the data for just to track. Maybe let's say there's robbery going on, right? The same robbery might happen in another location. That when you link them, you can know that okay, so this kind of robbery is being done by the same crew or the same people, and they can use that to make informed decisions later on. But the lack of data storage in Ghana is a problem. Yes. Anyways, I'm done lamenting about Ghana police. Any more? Anybody to add more to it? Anybody to add?
One last submission.
Okay.
Is it the various passport centers and also the National Identification Authority.
Right.
They have a database that they store details of those people who have been applying for Ghana card and also passports. Yeah.
Even when you are done applying, and they give you the card, you still like have access to your information. They still have access to your information in the database. So yes. Dennis, your hand is up.
Yeah, I say to add to that Ghana registry business registering authority like the registrar general, where they register businesses and take details of various businesses for both the record keeping, and then also they also use that to assist the Internal Revenue Authority to track various businesses. Yes, and then in collecting revenue and the others for the country. Thank you.
All right, thank you for the input. So you can see that our whole lives at the moment is governed by these databases. Like everything that we do, from paying of our electricity bills, from water bills, electoral commission, like voting, even being identified as a Ghanaian itself. Your data needs to be stored somewhere. So that is why we need to learn databases, understand them, and appreciate them. And then once people find love with databases, they can now become database managers. So they can manage databases for banks, for these institutions. And then also you guys are teachers, so to be able to teach the students how databases, how to use database, how to query the database, and then everything in between. So that is what we are going to be doing this block. Okay. So now let's talk about types and examples of databases. So we have distributed databases. It says that data is stored across different physical locations and processing is distributed among multiple database nodes. These database systems communicate over a network. Example of such databases are the Apache, Cassandra, the HBase, Foundation DB, the Couchbase, and then Ignite. So these are database systems, okay, that they are not collected and then stored and processed in one area, but then it's distributed across. Okay, so the examples are the ones that they've given us here. The type of database are the Apache, Cassandra. Please let me take this call. Person has been calling continuously.
Ahmed, continue what I say.
All right, thank you for your patience. And we also have relational databases. It's a collection of data with predefined relationship between them. Data in a database is organized as a set of tables with rows and columns. Now, relational databases are commonly known as SQL databases. Example of such databases are the PostgreSQL, MySQL, Microsoft SQL Server, and an Oracle database. Now, this course, you are going to delve deeply into the relational databases. So for them, the data is stored in a row and column form, so in a table form. So to retrieve them, you need to have the row name and then the column name to retrieve a particular information. And then we are going to learn about that as well. We also have NoSQL databases. So unlike the relational databases, the relationship between data are not predefined. And then the data is stored as a JSON document. So that's another way of storing data, a JSON file. And then instead of columns and rows used by the relational basis. Okay. So let's say for name, you keep the name in some form of a bracket, and then you store all the data about the person in a single line. So that one you write code. You don't use the table form to create your database system. All right, let's move on. I believe the assessment you guys can look through. So on the next section, we are going to talk about using file-based systems and then advantages of database systems. So those days that there weren't any form of relational databases, right? They used to keep all the information in the form of a file so that it can be accessed and then the things inside can be retrieved. But there was a problem with that. So we are going to talk about the problems of the file system. If you can see in the image here, okay, so let's say we have customer orders. We would have a file that has the customer file. Maybe the customer has their names and then their details. And then we have another one for a stock file. We also have another file for another file. Unlike the table, that's when you keep everything in a row and a column and then you create different tables and you link them together. This one, you have to create different files. And then you also have invoicing. So customer invoicing, you still create another customer file and then you do stock file and another file. So as time goes on, you see that customer file has now appeared a lot of times. And then it becomes difficult. It becomes difficult to, keep track of. And then sometimes you would have to write constraints on who has access to what. And then that one too becomes a problem because it's a file system. Unlike the way the relational databases, you can just give it's not priority, but you have to give users access. Some of them can't access something, some of them can only view the data. So just like the way school system is, lecturers are supposed to input your grades. The only thing that you can do is to come and view your grades and then come and check your timetable, come and register your courses. Those are the only things you can do. There are also somebody that is also on the system that can do something that the lecturers cannot do. You guys get it. So you can restrict access at a different stage, unlike the way the file system is. So let's go through it real quick and then we'll get to understand what a file system is. So they are saying that files are used to store information on a computer permanently until the file is deleted or the hard disk is formatted. And I believe that we have all gone through this problem before. You keep your file somewhere and then all of a sudden your machine stops working or is deleted. Or someone is trying to format their pen drive and they format your drive D or your drive C or something. So organizations such as manufacturing companies stored in the 1960s use operating system files as a means of storing information on a computer. Now, different programs as softwares were developed to allow users to manipulate the information in the files. So you can see in the image that I'm showing you right now, the customer orders, customer files. These are all different files that were created. Okay. All right. So for an example, if the manufacturing firm decides to store employees' information electronically, it means a new application program has to be developed specifically for that. New software is added to the system as the need arises. Now, as time goes by, the system acquires more files and more application programs. And the system is just described, that we've just described is called a file-based system or a file processing system. Okay, so they keep user data in the form of a file, unlike the way we are trying to keep it in the form of a table that you can access and then you can give restrictions on. Now let's talk about the drawbacks of a file-based system. So they are saying that data redundancy and inconsistency. So often within an organization, files and applications are created by different programmers from various departments over a long period. Now, this leads to the same information being duplicated in several places, just like the way we have customer file duplicated here, stock file here. We also have another stock file in the purchase order. We have stock control and the stock file is also there. So as times move on, you would have duplicated files. Okay. Now we also have data redundancy. The same customer information is duplicated in both customer orders, customer invoices, and you can identify some of the data which are duplicated in there already. And the redundancies leads to higher storage and access cost. It may also lead to data inconsistency. That is, the various copies of the same data may no longer agree because you have to now create a program for it. Sometimes you may get to a point where you are trying to access a file, but the program that you've already written to it may not agree with you. Another problem is data isolation. Since the data are scattered in various files and sometimes in different formats, for example, the customer order system might store the data in a text file while the customer invoice data are stored in an Excel file. Writing new application programs to retrieve appropriate data can be extremely difficult. So right now, let's say customer order system is stored in a form of a .txt file. Okay, so all the information of the orders that they come in are stored in a file. And then another file somewhere is like an Excel file, but you need to retrieve all this information as one. So trying to create new softwares for this becomes a problem because now one is stored in a .txt, one is also stored in an XLS Excel file. So like trying to retrieve them may become a problem. So that is the data isolation. So in a file system, that becomes a problem because it's not only one extension of a file, but then different extensions. And then trying to retrieve them and writing a program for them is difficult. And there may be security problems as well. So it says that unlike database system whereby each user of the system can be restricted to what the person can see, enforcing such security constraints is difficult in a file-based system. This is because applications are added to the file processing systems in an ad hoc manner. Okay, so that becomes a problem. Somebody that is not supposed to see a particular data can see it because, you know, as they keep on adding the files to the system, they might even forget to set constraints.
Morning, no.
Or if-
Oh, yeah. I'm sure double. My coffee, one of them.
Matthew.
Hey, might you again.
All right, so let's talk about concurrency. The concurrency is the ability of the database to allow multiple users to access the same record without adversely affecting transaction processing. So with a file system, one person can have a hold of the file, and then the others will be waiting for the file. If the other person is not done, there's no way the other person can have access to it. So imagine going to a bank, and then the tellers are all busy. So you want to go to the ATM side, and then if one person is not done with using the ATM, you know you can't have access to it. But there's a way around it where someone will just be like, okay, fine, the bank is busy, the ATM is also busy, so you can use your online banking app to get access to your cash, either withdraw it into your Momo and then go and take it out somewhere. That same time to Mr. Simon Dazi is also performing the same transaction somewhere else. But you see, unlike the two instances, one person has to finish before the other gets access. But with a database system, you don't need to wait for somebody else to finish their work. It works concurrently. So that's the problem with the file-based system or the file processing system. One person would have access to a file or will have access to the data, and then nobody else can have access if they are not done. Once they are done, before the access is given to the next person. Now, there's also an integrity problem. It says that the data value stored in the database must satisfy certain types of consistency constraints For example, the customer order amount should be above 200, or the stock quantity must never be below 100 times. Developers enforce these constraints in the system by adding appropriate code in the various application programs developed for each file. However, when a new constraints are added, it is difficult to change the programs to enforce them. If you've already added some few constraints earlier on, now if something else happens and you need to add more, it becomes difficult for you to change and enforce ones because the others were already enforced and being enforced on the file system. Okay. Now the problem is compounded when constraints involve several data items from different files. So let's say one program can have access to the customer file and then some other thing else. Now you want to also perform something on other files as well. Now you have to create another program and then have access to it. But some other program is also preventing you from having access to the other one because there's a constraint that has been set that you shouldn't be able to use it at this certain number of time. Okay. And then that becomes a problem in the file system. All right. So after hearing all this, okay, I want to give you guys few minutes. We take the data isolation and you tell me how you understood it. Okay. So let's start with the data redundancy and inconsistencies in a file-based system. Yes, anybody? Hey, you reach question time there. Matthew is quiet. Yes, anyone? I've already taken you guys through it, but I just want to know if you guys get it. Yes, Samuel.
So with data redundancy and the inconsistency.
Right.
Okay, so this one has to do with let's assume an organization some 5 years back was having a programmer or a database manager who was taking care of their database, and there's some detail that he created and also stored in a particular format, and now that person is no more and they've employed another person, and because that's not the same person who was working on this data previously, there is the likelihood or possibility that the same information which has already been captured elsewhere, you're also going to create it again or create another one, which is going to make it double. So here, the same information has been created twice or even sometimes more than two. And in doing so, sometimes assessing it, for instance, if maybe they are having the same name and then you are searching for it, you are going to get a lot of information with the same name. So yes, they are going to be confused. Which one am I looking for, or which is the actual information or data I want to access? So that's my understanding. Thank you.
All right. Is any other person? Any other person? Okay, let's move on to the next one. So we have data isolation. Data isolation. Oh, guys, and when we started, you guys were talking. I said, at this point, you guys have just decided to keep quiet. Data isolation or security problems. Anyone that you can explain well.
Okay, so
Yeah.
Okay.
please. So when you talk of data isolation, I say that it's the practice of separating and protecting data from unauthorized access.
Okay.
So meaning the data has been separated from unauthorized access. Those who are not having authority on it, they cannot tamper the data. I think that's my understanding of it.
Oh, okay. But in our
Or
case,
modify.
in our case, it's supposed to be a disadvantage. But now I'll take that for now. Yes, Ibrahim.
Yes, sir. Thank you. I think that with data isolation, it
Mhm.
has to do with having more than one file format containing
Okay.
details of various personalities you are working with. And
Okay.
because they are all in the same institution, you would want to retrieve a particular data from a file system and bring it onto another one. Because those file systems are incompatible, it becomes difficult accessing those data. That is
Right.
how I feel it becomes the data in those file systems are isolated.
Okay.
You wouldn't have a synchronized system of data database.
All right. So as I said, different file formats. So let's say your HR wing is using Excel to store data and then their operations. And then your other department is also using Office Word. And then some department is using TXT. Others are storing their info. I'm just making it up. Others are also using JPEG to store some of the data that they have. Now trying to have access to all these at once is going to be difficult. You get it? Because of the different file formats that is in your system. All right. Maybe the person using Excel is always using Excel to access it. But if you are someone that you need to use or get access to all these data at once, it's going to be difficult. You have to write programs into reading all these files so that you can have access to it and then, get it at once. Unlike the way the database system is, you just query the system, it gives you your picture, it gives you your name, it gives you your this, it gives you your that, and then you can update and then do any changes that you want to do on the same web portal and then you just go. This one, there are different file formats. Okay, that is the data isolation that we have here. Yeah, security problems and concurrency. Anybody to tackle that? Mr. Is it Ahmed that spoke? Or is anybody to tackle the data isolation? Sorry, the security problems and concurrency. Yes,
Please,
Mr.
I
Mo.
want to talk about the concurrency.
Okay, sir.
Yeah, so concurrency has to do with the ability or process whereby two or more people can work on the same project at the same time.
Okay.
And with the file-based system, it doesn't permit that. Unlike the the electronic or the cloud database system where people from even who are not in the same geographic location can even just connect to the system and then do what they have to. But this one doesn't permit this concurrence or on the go manipulation.
Right. There's any other person. There's security, there's integrity problem. I don't know if anybody have
Sorry.
had an instance where they have a video playing and they want to rename the video, and then you get a prompt saying that an application is using the video, so you can't have access to it. You have to close the application before you have access. And that's a concurrency problem. Imagine someone is working on a system and is using a file that you want to use. You can't use the file because someone already has it. Okay. Yeah, the rest, the security and then integrity. I remember someone was about to say something. Was it you, Ben? Oh guys, let's hurry up. I need to make sure you understand so that we move on to the other sessions. And I have a lot of time on my hands as well. Yes. It's my network, buddy. Hello.
Hello, we can hear you loud and clear.
Oh, okay.
Yeah.
So security problems. Albert.
Hello, sir.
Hi, Mr.
Hello.
Albert. Yeah.
Yes, on the security, with a
Mhm.
file system, it is difficult to restrict users to what they can see. So it
Okay.
exposes the data to all manner of people. But with a
Yeah.
database, you can restrict users to only what they are supposed to
They're
see.
supposed to see and manipulate. Okay.
Yeah.
All right. Then let's talk about the integrity problems. Anybody? All right. So advantages of database systems. So based on the difficulties that we have listed above, right, it made them to develop a new approach into managing large amount of organizational information and enlarge the database system. So the advantages of using a database system from the file-based system is number one, sharing of data. So there are various levels of authorization to access the data, and consequently, the data can only be shared based on the correct organization protocol set up by the database administrator. So users can access the data remotely and simultaneously, a feature which is not possible in a file-based system. And then we talk about increased productivity. And unlike the file-based system, whereby, let me highlight this one. All right, so unlike the file-based system, whereby a different application program has to be written to access a particular file, database system provides tools necessary to query, like asking the database what information one wants. For example, when dealing with sales data, one might ask the database what is the total amount of car sales in the past 2 weeks, and then transform the results into a usable information. This enables users to make quick and then informed decisions. Now it has increased concurrency as well. It says that in the database system, multiple users can read and update records at the same time. This is known as concurrency, as we talked about earlier on. And then unlike the file-based system, this has been happening throughout the bit. Unlike the file-based system, whereby the data cannot be accessed simultaneously. So file-based system, as I say, you can't use the data while somebody has it. Okay. So with the database system, all of us can perform transactions on the system at a go, and then the database will still be fine. Now, how the database handles concurrency will be covered in details in the subsequent session. So we are going to cover that in the sessions that are coming. So you can see that earlier on they had a lot of problems, and then those problems have been solved by introducing database systems. So first of all, you can share data amongst the correct users. You see, we had security issues at the top there where the users that the data is not really intended for them to see, they could still see it. But here you can restrict the people that can see it. You can restrict the people that can have access, and then at what level can they have access? All right. So let's say I actually give an example in a banking system. All right. You, the customer, can only come and do deposits, withdrawal, and then request for a loan. And then sometimes maybe you want your information to be changed. That's the only thing that you can do. We have somebody else with another function that they can also perform on the system. So they can also, update your details for you, put you on a when you request for a loan. So they will change the system will change for you to, for them to know that okay, so this person is on a loan. They can also go into your account and then edit some few informations in there without even you doing it yourself. So those are some of the ways that we've been able to secure and then make sure the people that have the access, and the people that don't have shouldn't have the access to a certain type of data or shouldn't be able to manipulate the system. And then we also have increased productivity. So because these systems keep general records, okay, so you can query it and then it will give you an information that you can use later on. So there's this recommendation systems right now that most of you are aware of, and then some of you are not really aware that it is happening to you every day. And then that's how it's it affects your social life in terms of social media. So if you guys have realized, anytime you like a video, let's say you like a funny video, the system gets to know that okay, so you've been liking this video for a while. So it will start giving you funny videos. The moment you switch your taste a little bit and then you start liking tech videos or videos talking about some tech products or like tech activities like cybersecurity issues, right? You start getting cybersecurity videos on your timeline. If you are someone that likes looking at girls dancing, you will also be getting girls dancing feed. So all these smaller actions that we perform on the system are also stored in the database, and then they use these companies mine that data and then use it for their good. So they know that this person likes watching this type of content, MPP NDC content. So I will just give him political content, and then later on, I'll just push somebody's adverts through it. Okay, or I'll just push some ads through it so that you can see it, and then if you want it, you can just go to the website and then buy it. These are ways that these systems are manipulating us. They actually know us more than we know ourselves because of the smaller things that we do on the system. So I mean, database systems has helped us to increase productivity in terms of business sense. That's okay. So I know that at this time of the day or at this time of the month, it rains a lot. So if I put umbrellas on sale, I know many people are going to buy it. And then you can query the database to check whether it's true that at that time of the year, okay, there are a lot of people buying umbrellas. So if you put umbrellas on sale right now, there are a lot of people that are going to buy it. At Christmas time, if you start selling knockouts, let's say you're those shops and you sell knockouts, you know that obviously people are going to buy the knockouts and then use it. So these are ways that it has helped us improve. So if like you have a system or a company that you keep record, you can also query these records. Even in Excel, you can query it and then it will give you an informed decision about how your business is going, which month is your best month, and then which product sells at which month. So that alone helps us. And I've also talked about the bigger companies like Google, like TikTok, and all those people. They use the data that we have, the smaller things that we do on the system, our likes and our dislikes and everything, to now give us the content that we like more. And then that way it will hook you on their app, and then you'll be able to push their ads to you, and then you'll be able to, click on it or buy something from them, and then help increase whatever they have, their profits and all that. Yes, you can also give more advantages. You can add some more advantage of database systems. Anybody? Anyone? Anybody?
Is it advantage of database system?
Yeah.
So I would say it is reliable.
Okay, explain that one.
Yeah, reliable as in a extent that the detail that are stored in the database system, you can have access to it at any time, and then you're also going to get the exact detail that had been stored or is put there.
All right. Yes, thank you for your input. Any other person? So just like the way I explained earlier on, let's say with the bank example, you could just be in your house, get access to your bank account, transfer the money into your Momo, and then use it to buy something. These days, you can even use the cards that you have, let's say MasterCard, Visa card, and then buy things online, AliExpress, Amazon, and then you still be there. Your bank will be Ghana, but you will still be using it to, perform some transactions abroad. Yes, Ahmed.
Sir, please, with the advantages of database, can you also talk about data recovery and backup?
Yeah, you can talk about that.
Okay, thanks.
So some of these systems keeps backup somewhere else. Yes, Pin.
Can you also say data integrity?
Okay, you can say that, but you have to explain it to me.
Yes, please.
All right, so we are
So
listening.
the database application management
Mhm.
can say that it provides accurate and complete information.
Exactly. So the data that you provide there might not be changed by somebody else,
No, except you.
except you that you have access to it. Okay. So if let's say your medical records, right? The only person
Yes.
that can have access to your medical records is your doctor. That's how it's supposed to be. And then maybe some physician assistants and some nurses. Those are the only people that have access to that. There are some level of records that is not everybody supposed to know. You get it? I mean, yeah, integrity is good. Any other?
So can you also say that it protects your data from unauthorized people?
Yeah, it does that as well.
Sir,
Yes.
please wait. The one our sister said, for a protect your data from unauthorized people. I have a
Mhm.
concern about that. So if
Okay.
database protect data from unauthorized persons or people,
Mhm.
then
Mhm.
we could also see the fact that some people also hack some people's data and then make sure they manipulate some information from it. That how and how can that become advantage of it?
So you see, at first, right, it was even visible for you to just open the system and just have access to it. But now, hacking means you have to go through different methods of breaking a particular security that you have on the database before you even get access to it. And then even these days, guys, it's really difficult unless you use a lower security measure to protect your data from these unauthorized access. Plus, sometimes too, because we give privileges to people on the system, they will pass through somebody to get access to it. So they will send you some random links. You just tap on it. You think it is the portal that you either withdraw your money from, or it's a portal that you use to log into the system to use. Let's say you're a database manager working on UCC system, and you receive a link, and then you tap on it, and you think it is the portal that you use, and then you input your passwords inside. Now, this hacker somewhere has gotten access to your password, your email that you use to log into the system, and then they will use that to log on and then do anything as if you were the one that you were doing it, but it wasn't you. They call that thing social engineering, where they go through people to get access. So they can be your friends, they can come and hang around with you, they can even go to an extent by like watching the way you open your passwords. So all these things are there. It's not only when someone uses code to break it. Sometimes they pass through people to get access to the database as well. But there are implementations like the SHA algorithm, which hashes the data that goes into the database. So even if someone gets access to it, the only thing they see is gibberish or just random numbers that they see. So some of these systems have hashes, and then some of them they have low security measures, which is easier to break into. So yeah. Yeah, Sammy, your hand is up.
Yeah, I wanted to say something with regards to the question my brother asked.
Question mark, okay.
You-
Oh,
Yeah.
I'm really happy if you guys contribute.
Oh, okay, okay. So I think you've said it all, but I would want to add something small to it. So,
Please.
yeah, in terms of the unauthorized access, comparing the database to that of the file system, you think the database is having an upper hand, even though it is possible that someone may do something else to be able to access some information. But comparing that one to the file manager, you see that one is far better. Except yourself, you are not proactive enough to protect your system with an advanced security system. So in terms of security, I think the database is having a higher upper hand. Because even on your normal laptop, someone can hack into your system and then they take away the relevant information that they want.
All right, thank you very much. Any more to add? Any addition? Any advantages? All right, so if there are no advantages, let's move on to abstraction. So you see that normally even the inner workings of computers, most of us we don't know. Even the keyboard, how the keyboard works. Why is it that when I press A, or how is it that I press A and then the machine understands that this is A and then it gives it to me, even though they've already taught us that computers understand only zeros and ones. So how did they do that? So all these ones are not relevant to you, the user that you are using it, unless you are being curious. You understand? Unless you are being curious about it. Just like the way they have given us an example here, that anytime we want to play a video, okay, we just double tap on it and then just allow the player to play it for us. Whatever happens in between the physical level of the computer, we don't know. And we don't need it because we just want to watch our movies and move on. Imagine you want to watch a movie and they tell you that so the movie is encoded in this, and then the encoding you have to have these zeros and ones happening, and then the file has to now be moving from the RAM to the CPU. Now the CPU sends signals to all the physical layers that is attached to the video. So let's say to watch a video, you need the access to screen, you need access to the speakers, right? And then you also need access to keyboard to control the video. All these things you don't need it. This information you don't necessarily need it. Or let's say you want to perform a bank transaction, and now you have to learn how to write the code to perform the transaction instead of just tapping on a button and then just having access to it. So that is a abstraction. Abstraction is where we hide the things that are not relevant for users, and then we just move on to do what we are intended to do or we are supposed to do. So it says that abstraction simply means hiding unnecessary details. Humans use abstractions all the time, almost without thinking about it. So the example that I was talking about, you're able to download a movie to watch on your computer without knowing anything about how the video is stored on the computer. How you were even able to download the video in the first place from a server that is 1,000 miles away from you. You just connect to the internet. How the signals traveled from the telecommunication mast all the way to your machine, sorry, all the way to your phone, through to your machine to download. It's just too much information that you don't need. Or the only thing that you need is download your video and watch it. So that's how powerful abstraction can be. All the details of how the computer does the video processing are hidden behind nice buttons on a video player, for example, VLC. And that's that. Somebody's hand is up, or they just joined the meeting. Okay. So with that understanding, what do you guys think data abstraction is? Yes, anybody? We already have the slide, so I'm sure most of you have gone down there. Anyone to help us with it?
Okay, say
Yeah, Mr. Samuel.
yeah. So with the data abstraction,
Mhm.
this like we've already explained abstraction to be
Mhm.
we are hiding the unnecessary details or information about the data, and then we are only going to have access to what's important or what we are going to use. The
Mhm.
data abstraction will also be like you are not going to see or wait for like to see all the mechanisms the data goes through or pass through before you're able to get the final result. But
Yes.
you only get the most important thing you have to get and what you need to work on with. So that's my understanding of data abstraction.
Yeah.
You're only focusing on the most important
The most
aspect of the
important thing. Yeah.
yes.
Is anybody else? Anyone? Anybody to add to what Mr. Samuel said? This one is an easy AU. Anybody? Queen, are you going to save us?
Okay, sir.
Yes, sir.
So with the data abstraction, I can say that is how you hide the complex details of how data is was stored and managed.
Okay.
Yes.
All right. I like the short definitions you guys are giving. So, if you want to check your bank balance, the only thing that you just need to go and tap is check balance, and then you see the amount of money you have in your account. But there are things that goes behind this that goes on behind the scenes. And then if we are supposed to allow all the users to be able to do that, will probably be difficult because it's not everybody that is computer inclined or IT inclined enough to go through that. So imagine checking your bank balance. Instead of tapping it, we tell you that write a query to check your bank balance. So select from my account where the username is this, the password is this. So that's what everybody's supposed to type before they get to see their bank balance. You see the level of detail that is involved. It will even bore people to even want to use your system in the first place. That is why we do the level of abstraction to be able to hide some things that some users don't need. So this select from where it is you, the database administrator, that you need it. But for the end user, they or no that code, he doesn't need to even think about it. You just have to press a button and whatever the query is behind the button that you press. Okay. So hiding everything into a simpler way so that people can just use it without thinking too much. To me, it's called what data abstraction. So let's see what we have here. It says that a database system is a collection of interrelated data and set of programs that allow users to access and modify this data. To ease the user interaction with the database, the system hides internal irrelevant details of how the data is stored and maintained. Now, the process of hiding irrelevant data from users is called data abstraction. Now we have levels. So it says that since many database system users are not computer trained, developers hide the complexity from users through several levels of abstraction. So there are levels of abstractions. So some particular people understand some levels, and then others, since they don't need it, they can just only see the UIs that you've created, and that's what they use. Okay. So the first level is the physical level or the internal schema. I want someone to take this and explain it to us. So it says that this is the lowest level of abstraction. It describes how the data are actually stored in the hardware and also how the data can be accessed. The physical level shows the data abstraction at the lowest level and it has complex data structures. Only the database administrator operates at this level. Now, who can break it down for us? Who can expand it for us? Yes, the physical level.
Please, I want to try.
Please try, okay?
Okay. So you see, when you were explaining the types of database, you talked about is it distributed something?
Yeah.
Yeah, where the data are stored in a physical component or physical hardware. Yeah, so
Spread,
my understanding,
it's spread across different,
yes, yeah,
yeah.
different hardware components. So my understanding of the internal schema or physical level is that um the the database administrator himself, he he determines how those who are going to access the data, how they can access it, and also how the data is actually stored in the physical hardware.
Mm. Okay.
Yes, so that's my understanding.
Oh,
So
okay.
this one will be determined by the person who is actually working on the database, the administrator himself. He is
Okay.
going to determine how the data is stored in the hardware component, and also how the users, the people who are going to work with the database, how they can access it.
All
Thank you.
right. You're welcome. Yes, any other person? The physical level or internal schema? The physical level. Mr. Opoku, Mr. Foster. Hello, Mr. Foster. Yeah, Ahmed. Ahmed, go on.
Hello, sir. I think my explanation may be a little bit funny, but just accept it like that. But
Okay.
with regards to physical level, I can say that here, assuming you want to fill a form online, or let's say you are in a bank to maybe open a bank account, you may be given a hard copy for you to provide your details on it. Apart from that, when you are done with the forms, you send it to maybe the administrator to operate it or pinpoint every information on the hard copy onto a database. So I
Right.
think that a physical level.
Okay, any other person? Okay. So let me take it. So the physical level or the internal schema, it says that this is the lowest level of abstraction. Now it describes how the data are actually stored in the hardware. So let me take Mr. Ahmed's example. Now, first of all, if you want to create a bank account, let's say with your paper-based something, someone have to design and develop the form itself for you to use. Do you get it? So now, if you are supposed to take the data, how the data is supposed to be taken itself, okay, is part of the physical level. And then where next to go to when the data is taken from the user? Should you go to the administrator? Should you go here? That one too is part of the physical level. And then how the data is going to be worked on later is also going to be involved in the physical or internal schema. So in our case, the type of storage that we are going to use to store the data, the physical level and is supposed to handle that. At what time is the system supposed to update itself based on the data that you give it? Also internal schema. That's the lowest level. What are the codes that we are going to use? What are the database types? Are we going to use Oracle? Are we going to use MySQL? They are also parts of the physical level. Okay. So the physical level is like the base for how the system is going to, how the data is going to be stored, how it's going to be worked on, the type of hardware that we are going to use to store the data, the type of language and queries that we are going to, write for us to transmit the data into the storage. All these ones is part of the physical level. Okay. And then he says that only the database administrator operates at this level because he's the one that knows the ins and the outs. He's the one that knows all the protocols. Okay, so that is the physical level. I believe I have explained it enough. Or you guys are still lost. And then we have the logical level or the conceptual level. Now it says that it is a level above the physical level. Here, the data is stored in the form of entity sets. Now, entity sets or entities. There are data types and relationship among the entity sets. User operations performed to retrieve or modify the data and certain constraints on the data. The logical level does describe the entire database in terms of the small number of relatively simple structures. There's one more feature that you should keep in mind, which is data independence. And that's changing the data schema at one level of database must modify the data schema at the next level. And it is the developer and the database administrator who operates at the logical or the conceptual level. So this is the second layer. Now this one, you are now performing logical operations on the data that you have in the system. So that's where you link some tables together. So let's say with a school example, we have teachers, we have courses, we have departments. Okay. Now every department manages a course, and then every teacher in a department also teaches a course. So this is where you link and then you perform all the logical on the data that you have in the system. So on the entities that you have in the system, this is where you perform all those relationships, you perform all those matchings, you perform all those one-to-one relationship, one-to-many relationship and all that. I believe you guys get it. So here, this is where you set, sometimes you also set some form of, programming there to link all those data, all those entities or tables that you have in your system together as one, and they can now operate as a whole entity. Yes. Who can also take what I just said and then, modify it a little bit for us to know how they understand the logical level or the conceptual level. Anybody? I want to know from your opinion what you understand by the logical level. Hey, like this one, you guys are quiet too. Ahmed, do you have something for me?
no, sir.
Albert, say something. They say something. What do you understand by the logical level?
I want to perform some raw guys talking still.
Yeah, perform it. We'll drink it like that.
So my understanding based on the explanation you gave is with the logical level or conceptual level, the data is being put into different or separated into different entities or groups, or let's say into various departments. Yes.
Okay.
And then these departments, like they all come together as one. Like they are working interrelated to perform the same function, but they are all holding a different set of data, and then with a different level of should I say accessibility or what you can do with them.
Yeah.
So it's more or less like a government. You have arms of government. They all perform different functions, but what they do is what makes the government. So that's the little I can say about it.
This Gary tokens is lacking some little bit of sugar, but thank you. Yes, Ahmed. Ahmed, I know you have something.
And
so can you just say that with a data abstraction, logical level.
Yeah.
Describe how data is stored in a database and how the data is related. But here, not how it is physically implemented.
Yeah.
That's what I can say. If I have to add some salt to my soak user, just tell me.
Try and add some granules to it. There's anybody else to take us through? I mean, so right now you have already implemented a system in the physical level. You've shown us that your data is going to be stored in this storage device or drive or wherever you are storing it. The path to that particular storage has already been set. The type of data is set. How people are going to access the data is also set. Now you have the data in a system already, and then these data are in different tables called entities. Now at this point is where you link your entities together in a form of relationships, in a form of logical relationships. As I explained earlier on, we have a teacher as an entity, and the teacher has attributes, or he has some properties that show that he's a teacher. First of all, he has a name. He has some course that he has to teach. He has to be assigned to a class that he's teaching. And then we also have departments. So departments also have the courses in them. And then you also have the number of students that are going to be taught in them. It also has the teacher belonging to the particular department. And sometimes, even if you don't belong to the department, you can still teach from a department. Okay. Now, how do we make sure that a teacher can have access to a student's record and then edit it? It is the logical level. That is where we take all these tables and then we perform some logical relationships between them, so that if on the teacher side, if I open the portal, the only thing I can do is to access students, is to grade or access students, is to mark attendance, okay, or give assignments online or something. And then on the student side, they can only see their records. So the relationships that we perform and then the code that we write to bring all these data together so that everybody can see their parts and then not overlap is at the logical level. Please, I hope it makes sense.
Yes, sir. But sir, please have a concern. So here with electronic, what do you call it? Report cards we've been filling. Sometimes some of them have been programmed in such a way that after entry, the data can also be sent to maybe a core tutor to look through and make amendment about it. Before maybe submitting it to the administrations to or be forwarded to the students.
Yes.
Okay.
So in this way, everybody has everybody's an entity. So the teacher is an entity, and then the senior tutor or the senior teacher is also, it's like a branch entity from, he's also a teacher as well, just that he has level of privileges that you don't have.
Yeah.
So you as a simple teacher will just have access to your class and that's it. The senior tutor will have access to all the teachers' classes. So let's say the head of department, let's use it that way. So the head of department will have access to all the lectures and then all the grades that they give. Now, these are the logical things that you have to perform. There are codes that you have to write so that the HOD is supposed to see all the lectures assessments, as well as all the teachers all the students that they teach. Okay. And then he has to also perform some, amendments to the grades. Maybe the E's are becoming plenty, so he has to change some few to D or something, so that he doesn't feel a lot of them. So that's him and then his privilege. Now, when he's done, that's it. That's where his privilege ends. He submits it to administration. Administration also has some few things or some few some other privileges that he can also perform on the data. So before they now publish it, and then the student get to see it. So with administration too, they would also have access to different departments, and then individual teachers in those different departments, their grades that they've inputted. They can also perform some form of, data manipulations there before they submit it. So all these all these code that you be writing, so that this person will have this privilege, that person will have that privilege, that person can only see this when they log on, is done at the logical level. That is where you relate all the tables together, and then you make meaning out of individual entity and what they can do on it. Please, I hope everything is okay now. I hope
Yes,
you
sir.
understand it now.
Yes, sir, please.
All right. So we have the last abstraction level, which is the view level, the user level, or the external level. Now, this is the highest level of data abstraction. It describes only a part of the whole database. It exhibits the data in which the user is interested, and the system may provide many views of the same data. The view level of abstraction exists to simplify their interaction with the system. And here the user retrieves the information using different applications from the database. So this is the view, the last level. This is where almost everybody is going to be at. This is why you don't need any level of understanding. You just log on. They just give you the either the application that you are going to use to access the data, or a web portal somewhere. They give you logins. You just log on, and then you just be pressing buttons to perform the things that you have to do, and that's it. So in this case, the lecturer, as grading the students, is at the view level, and then the students opening their portal to access their grades is also a viewer level. This one you don't need any coding. There's no coding involved. All the coding, all the modifications, the hardware that you use, everything has been done already by the database administrator, and then the people that are the programmers that operate, or the developers that operate at that level. At the view level, there's no form of programming that's happening because everything has been done swiftly and easily for you. Okay. Please, I hope that one is clear. So just like the banking app like this, you don't need to write any code. You just need to check your balance. So you tap on balance statements. You just want to transfer some money to somebody. So you just tap on transfer money, and then you'll be met with a form. So you select the amount, you type the amount you want to send, you select the account you want to send it to, or you type the account number in there. You just press send. All the code and everything has already been done at the back end. You don't need to even see it. That is the view level. That is the view level abstraction. So this one, you don't even see any code. You don't see anything. You just see UI, and then you just use it. Any question? Any questions so far? So to understand this one, there's an image on the screen, figure 2. Now you see that the physical level involves the physical components that you'll be using. So the storage medium, the process that the data is sent and then stored in the database, everything is at the physical level. And the logical level is how you relate the two entities or the multiple entities together. Okay. And then the view level is the level where anybody can just get access to the database and use it per the restrictions that they have, or per the things that you can do on it. And that's it. All right, any question? Any questions so far? My people.
Sir, I think we can proceed.
Okay. So let's talk about database schema, and then we'll go for a break. Now, the design of a database is called database schema. Database systems have 3 types of schemas divided according to the levels of abstraction. You remember abstraction that we just did it. So yeah. So we have the physical schema. Now that one describes the database design at a physical level. That is how the data are stored in blocks of storage on a hard disk. the physical schema can usually be changed easily without affecting the logical schema or view schema. Application programs are said to exhibit physical data independence if they do not depend on the physical schema, and thus need to be rewritten if the physical schema changes. So the physical schema, as we said, with the physical abstraction, is basically the design of the database at the physical level. That's the storage that you use and all that. Now, when you change some of these schema, it doesn't change the logics. It doesn't change the code that you've written. You just change where to store the data or how to store them. Okay. And we also have the logical schema. It says that the logical schema describes the design of the database at the logical level. Now, a logical schema is the most important in terms of its effects on application programs, since programmers and database administrators develop applications by using the logical schema. So if maybe a table gets missing in your database, that one, it becomes a problem, because let's say you are trying to link it, it's going to become a problem. You get it? Maybe there will be a missing, they will tell you that there's a missing table, or there's a missing record, or you can't, identify anything. So the logical schema is the most important one, because that's where we sit. That's where we program, we write queries, we update it and all that. So if maybe something changes there, it will affect the whole application that you are using. And then we have the view schema. It describes the end user interaction with the database system. It is the design of the database at the view level. The database may also have several schemas at the view level, sometimes called sub-schemas, that describe different views of the database. So what somebody will see will be different from what other person will also see as well. So those are the database schemas. Now, this is how I've been saying table. This is how some of these entities are. So with course, we have course ID, we have course name, we have department. We also have student ID. So with students, we have student ID, we have student name, and then course ID. So imagine if this particular table, okay, is lost from the system. It means that logically now these ones are not they are not complete, and then that will become a problem. So if you are trying to assign a student to a particular course, because the student's table or the student's record are not there, there may be problems. That's why they say that the logical schema is the most important in terms of its effects on the application programs. So that is that. Any more additions or subtractions? Any more inputs that you guys will give? I believe that at this point, everybody understands to this level. All right, Mr. Samuel says everybody understands, so that is that. Any questions so far? Okay, so if there are no questions, then we go for break, and then when we come back, we continue from there. So we'll continue from session 4. All right, so I'll see you guys in a bit.
Okay, so
Please, how many minutes?
I think they said we should give, I think it's 10 minutes or.
Okay.
By the way, you guys are quiet. It looks like you are tired. So let's make it like let's
20.
make it 20 minutes. Yeah, 20 minutes is fine. So
All right.
at my time it is 9:07. So let's come back at 27.
okay, so
Or let's do it 30. Why? 30, 9:30.
Sure.
I'll come back at 9:30.
Sure.
Okay. Thank you, sir.
You're welcome.
Bye.
Bye.
Hey, Ahmed, 9:30. Sure. You.
Some of the teachers give us 15 minutes and 10 minutes, and he's giving us 30 minutes. Won't I be happy? You know how I'm tired. In fact, I have a lot to do.
Hey,
even my work I have not finished. So that 30
And
minutes
the
time.
work now, when are we submitting it?
From now on, there you people should stop submitting because the
No, we
work
are just asking because
they said we should submit it this week or so, but the mode of submission will be communicated to us. And now we've not heard anything about it. So
they are not serious.
even, even if they postpone it to next week, we'll be happy. Or you are done with yours?
No. Are we doing one and now two?
You are doing 2 questions. You
Two
see,
of them.
it's more or less like the question 1. You are going to design 2 posters, so not 1. Yeah, it's yesterday that
No, are we doing question 1 and 2 or only question
yeah,
1?
question 1 and 2.
Like anyone.
Question 1 and
Question
2.
1 and 2.
Yes, please.
Hey,
A, dear A.
20 marks.
Yeah, 20 miles. Oh. Yeah, 20 miles. Sometimes you have to travel to somewhere and go and design only the background and come. And the next day you go and continue. So it is not easy. What about the post? The post, have you finished yours? Queen,
Yeah,
the post, have you finished yours?
I'm on it.
It's not
I'm
easy.
done with fun. I'm on it.
For you to even get the actual test. Okay. Apia has finished long ago.
Who?
Apia.
Who? Yeah. He's ICA. All right. Have a nice day.
Okay, same to you.
Bye.
Hello, guys. Hello. Yeah.
I say.
Okay. So I believe we are all refreshed now, so we can come and continue. We only have 3 sessions left, but then the last session is just history. So I'll probably give it to you guys, and then you guys will go and read. So let's just finish session 4 and 5. And then I can let you go. Okay, so to continue from where we left off, let's do database instance. When someone says an instance of a database, what does it mean? So the data is stored in a database at a particular moment. Sorry, the data stored in a database at a particular moment is called an instance of a database. So at a particular moment, the data that is there in the database at the moment is called the instance. So they give us an example down there. So assuming we have like 50 records, okay. At that time, that record or those records are the instance of the database at that particular time. But then after a couple of hours or days, we have 100 more added to it. Now, the instance currently will become 150 because the new 100 that we added to it will come and add to the old ones that we had, giving us 150. So that is an instance of a database. The current records that we have in the database becomes the instance of that particular database. Any question? Any question? Any addition? All right, let's go to data models, or let's try and understand what a data model is. So a model is a representation of reality or things in the real world. When we say a model, that is what we are trying to, talk about. So anything that we try to represent from the real world is called a model. Now, knowing that data model means that a collection of conceptual tools for describing data relationships, data semantics, and consistency constraints on the particular data. A data model provides a way to describe the design of a database at physical, logical, and view levels. It underlines the structures of a database, and then in the subsections that we are going to discuss, we are going to introduce ourselves to some of those data models that we have. But based on what I just read, who can, in their own words, tell us what data model is? Ahmed, do you have something to tell us?
Okay, so from what we read, I can also define data model as a conceptual framework that defines how data is structured and organized in a data.
Hello.
Yeah, hello, sir.
Yeah,
I
are you done?
said, in my own opinion, I can also define data model as a conceptual framework that defines how data is structured and organized in a database.
Okay, but can you bring it down? Can you break it down to our level? The level of we not understanding anything about the conceptual, the framework that
Or is a way that data is organized and manipulated in a database. referring to how the data is being organized and stored.
Okay.
And how it can be manipulated or maybe do addition or inclusion in the database system.
Okay. All right. Any other person to add up to what Mr. Ahmed said? Any other person have another insight, another angle to come from? Mr. Albert Moses. Mr. Albert, are you in the class?
Yes, sir, I'm here.
It looks like most of you are not talking today, so I would have to, question all of you to see if I am talking to real human beings or they are bots on it, or someone is. Anyways, Albert, so what do you think data model is after everything we read or everything that's you can see there?
Okay, so from your explanation of a model, you said that it is used to represent what is in the real world.
Right.
So we can say data model is a way that you want the data to be structured.
Okay.
How the data is to be structured. Yeah.
Okay. I'll take that one. Mr. Benjamin will also answer. Mr. Ben.
Okay, sir. I think I'm also in agreement with what my brother said. How the interface of or the data will be like. And that's
Okay.
what I have to say.
All right. So you guys are having amazing voices and you are hiding them. Yeah, Mr. Dennis, your hand is up.
Yeah, yes, sir. It's the way of organizing and defining data and its relationship.
All right, that's nice. That's nice. Isaac Odum, Mr. Isaac. Mr. Isaac. Mr. Isaac, are you there? All right, so we know that Mr. Isaac is absent, even though he's present. Mr. Etonam.
Please, she's a lady.
She's a lady.
Oh, sir, please,
Hello, sir. Mr. Isaac. Hello,
no,
Mr. Isaac is here.
Mr.
Mr. Isaac is here, sir.
Etonam, my apologies. I'm sorry
Hello,
for not
sir.
being
Isaac is
sorry
around.
for being gender biased. Isaac, tell us something.
Concerning the data model.
Yes, please, concerning that one.
It's about bringing your idea about the data into reality. So the underlying word is reality. So that is what I understand is about it.
Okay. So I like the part that you said
the physical replica.
Yes, of reality in the database system. I mean that's what you mean.
Yes. Yes,
okay.
Please.
Etonam, please can you add your voice to what the gentlemen are saying?
So, like he has said it. So
you add your voice.
Yeah, like representing the model in reality. That's a data model.
Okay.
Or representing.
All right. So we do know that when we take the school management system as an example, right? We do know the entities involved. You know that at least for a school, we would have teachers in it, we would have students in it, we would have let's say other workers or other staff, which administrative staffs, and all these people are like real life people, and we would have to bring them into the database by trying as much as possible to find ways to modify those details to to make us know that okay, this is a particular person or this is a particular entity we are talking about, the teacher. The teacher will have a name, the teacher will have age and all that. So as the students would also have age, name, and all those things. So trying to, bring all of them into the system to make it understandable in real life, just like the way it is in real life. That is what data model really is. Trying to model what is in real life in the database system. So let's say if we take car manufacturing company like this, you know that they obviously manufacture cars, and then I'm sure it's not only going to be only like one car. So let's take Honda as example. So Honda have the Civic lineups, it has the Accord lineups, and then all these ones too would have different colors to associate different model names. Okay, so trying to bring all these details into the database to make it as real as it is what we call data model. So we are trying to bring the real world into our database by trying to find ways of describing that particular data. How we are going to set constraints on that to let us know that okay, this one is a red color, this one is a blue color, and then so on and so forth. So that is data model. To me, how I'm going to like explain to a layman to get. All right, so in data models, there are types. So we have the relational model. That's what all of us are going to be using. And then we also have other ones. Somebody's mic is on. All right, so in a relational model, the relational model is the most widely used data model, and vast majority of current database systems are based on the relational model. It uses collection of tables to represent both data and the relationship among those data. The main features of a relational models are all the information is stored in a form of rows and columns. That's the basic structure of a relational model. And then tables are also called relations. So table students, table teacher, table department, table course. These are all called relations. Each table has multiple columns, and each column must have a unique name. You will see an example down there. And it says that each row in the table is called a tuple. So in case you don't hear me say row and you hear me say tuple the next time, we are talking about rows in a particular table. Now we are saying that a row contains all the information about any instance of the object. So let's say we are talking about a teacher, right? Teacher has a table. So we have the row for name of teacher. So we have Apia Kubi, we have Benjamin Owusu and Sam, we have Dankob. So those ones are the information that the rows are going to contain. Okay. So when you look at the example down here, so this is a table, okay, and then these are the columns in the table. So the first column have a unique name called MID. So this one is for an employee management system. And then every employee has an ID, just like the way every student has an ID. Or if you work in a company, how you guys have teachers' IDs and teachers, what do you people say it? I think I don't know if it's a teacher's code or something. And then we have the EMP name, that's the employee name, so your name, your job name, and then your salary and all that. So this whole thing is just it's a table for an employee. Okay. So this is what we are talking about. Now we are trying to bring what is in the real world into a database, and this is how we do it. So first off, the main database or the main table is for an employee details. And you know that every employee would have an ID. Every employee would have a name, would have a job name, what they do in that particular business or that particular organization. The amount of money every employee receives, the mobile number of the employee, department ID, project ID. So if they are working on some projects, you can also use an ID to, identify the type of project they are working on. So that is that. So each row is called a tuple. So each row that you see here, so John's row, Adam's row, these are all tuples. Okay. Now, attributes or fields are properties which defines the table or relation. So the value of the attribute should be from the same domain. In the figure below, we have different attributes of employees like emp ID, emp name, job name, and etc. So the employee being the main thing would have attributes like his ID, his name, the job title or the job name that he does. Okay, just like the way we have here. Please, does it make sense?
Yes, sir.
Okay. Now we have entity relationship model. Now, entity relation model, also known as ER model, is a high-level data model diagram, which is widely used in database design. The ER model uses a collection of basic objects called entities and relationship among these objects. An entity is a thing or a subject, sorry, a thing or an object in the real world that is distinguishable from other objects. So in this model, objects or entities in real world are represented in pictorial form. The ER diagram is used as a visual tool to represent an ER model. So I've always been saying that a teacher, department, and all that, but this is an example of an ER model. So let's say this is a student management system or school management system. We have a teacher here with attributes like teacher ID, teacher name, mobile number, salary, and age. Now, this particular teacher has a relationship with the department. That is, the teacher works for a department. So you see that this diagram is now giving us an overview of the entire entity relationship or the relationship that is going to happen between the department and then the teacher. And you can see that the department also has attributes like department ID, department name. Okay. Now they are related because a teacher works for a particular department. Okay. So this is how the ER diagram looks like. So it says that the following are the main components in an ER model. Entities. So an entity is a real world object or person. So it says that it can be a person, a place, or even a concept. For example, teachers, students, courses. You see, courses is not a person, but it's a what is it even called? It's a concept. Okay, we don't have courses as a person or as an object. It's just a concept that we can work our way around and then assign some books and things to. And then we also have buildings. So buildings will also become an object. And then we have departments. These are all some of the entities in a school management system. So we also have attributes. So an entity contains a real world property called an attribute. Now these are characteristics of that particular entity. For example, the entity course has the property like course code, course ID, course name, lecturer, and program. So the lecturer that is assigned to that particular course. And then we have a relationship. So that one is a relationship that describes how an attribute is related to one or more different attributes. For example, a teacher teaches a course and also belongs to a department. Students register for a course and a building belongs to the department. If you register for a course, you obviously have to go to a class. You have to be assigned to a class that you are going to study in. And that particular class also belongs to a department, something of a sort. Okay. And that's the diagram. But I want us to take another system and then we try and find the entities, we try and find the attributes, and then we try and find the relationships between them. So let's take this the smaller mobile money system, just the mobile money system. So first off, what do you think in the mobile money system? What do you think the entities are? Yes. Hey guys, I'm waiting. Yes,
Yeah,
Frederick.
sir.
Frederick, your hand is up.
Please, in a mobile money system, an entity can be a transaction history.
Okay. Okay. Okay, it can be transaction. So with a transaction, you can have the type of transaction that occurred, the transaction ID, the between the people that the transactions occurred between. So the if it is between a vendor or no, the infant say we know. So let's move on. As I'm seeing all the entities. Yes. What are the other entities that we have? So transaction here is not a person or an object. It's just a concept. Yes. Prince, your mic is on. Oh. Let's take Al Hassan Abubi. Mr. Hassan.
Yes, sir.
Yes, I really hear you. I really listen.
Okay, I think it can be customer name too. We can identify customer name.
Okay. So you see, the customer name becomes an attribute to an entity. I don't know if it makes sense.
Okay.
So now, who is the entity now, or what is the entity here? Mr. Hassan, this one is even it's around your nose. So yes, Prince.
You have the vendor as an entity.
As an entity, yes. And then Mr. Hassan said the customer's name, but the customer is actually the entity, and then the name becomes the attribute of that particular customer. Yes, what else? What are we also missing? There are other ones too. There are serious entities that we need to also see. Yeah.
Okay. So can you also talk of the organization itself, which is MTN as another entity?
Exactly.
Yeah,
The telco
the
is another one.
Yeah.
So this one, a particular customer belongs to a particular telco. Okay. You see, we can do cross transaction. You can send money from MTN to Vodafone, sorry, to Telecel, and then Telecel to MTN, and then Airtel to Go and all that. So all those ones to become entities, right? Yes. Any other entities?
Sir,
Yeah.
please, can we talk of, for instance, WhatsApp as an entity?
We are really talking about mobile money system here.
The mobile money system. Oh, okay.
Yeah, I don't know how the WhatsApp gets to. Yeah. All right. So we've identified move. Yeah, somebody wants to say something.
Yeah.
Yeah,
So you see, with the mobile money, sometimes you, the customer, you can go and send money to another person. So in this case, you, the person going to make the transaction, you are an entity, and also the receiving end also becomes another entity.
is an entity. Yes. So if it's between the vendor is an entity. You, the customer sending the money to you, are an entity. If there's a receiver that's supposed to receive, but you're not just withdrawing, that particular person also becomes an entity as well. So he too becomes a customer entity. So we can just base them as one customer, like an entity as a customer. Sammy, does it make sense?
Yes.
Even though he's at the receiving end, he's still a customer too. So we can just classify them as one.
Sure. Okay.
Yeah, Ben, you have something to say?
Yes, please. So please, can you classify the contact numbers of the customers as entities?
It's going to be hard because you being a customer, it becomes your an attribute for you to the customer number. But the reason why we are using the telco is because now the telco becomes another entity where you have to send your money to get to the other entity. You get it? So yeah. And then your number also determines the that one too will be another question to the Mame fan to answer. So after knowing all the entities now, I want to pick one entity and then we expand it. So let's pick the customer as an entity. What do you think can be an attribute to the customer in this case?
Say his name and then his telephone number.
All right, his
Or
name and telephone
account.
number. Yeah, so the moving can be. So let's say his name. Frederick, your hand was up. Mr. Frederick.
Hello, sir. Please, the customer's number can be an attribute, and also
be an
date of birth and then password.
Okay, so your PIN, your Momo PIN is an attribute. Yes. Dennis.
Can you talk of the transaction ID of the customer?
Yeah, I mean every transaction that happens is there's an ID on it. So yes, yes, transaction ID as well. And then we have the telcos the customer belongs to. That one too can become an attribute. The location, your Ghana card information, all those ones are attributes. All right. So another model-based system is also called object-oriented model or object-based model. Now, this one is more of programming. I don't know if any of you have heard about object-oriented programming before. Now, it's like representing an object in the real world in a programming way. So you create an object, you instantiate it, and then you start using it for multiple times. And then with this one, you only use one code there to do that. So this is basically in C++, Python, and then that's how we come about with the object-oriented models for databases. So it's not all the time that you have the relational models or the ones with the table. Sometimes you have to represent them in a form of objects, and then each object will have an attribute or a property. So yeah. And then we also have another type which is called semi-structured data model. They use XML, and their syntax and queries are different because it's not all the time that everybody is going to have the same attributes. Sometimes the attributes are different. And then in order to make work easier and faster, people tend to use XMLs or semi-structured data model for their work. So these are types of data models that we have. We have the relational data model. So we have the entity relationship model. We have the object-oriented, and then we have the semi-structured data model. So those are the. Let's move on to Unit 5. We talk about the data languages. All right, so in introduction, we have a simple brief. It says that one might ask, how do we store data? For example, students' records into database. Unlike the file-based system, where a new program has to be developed for storing students' record, database systems provide languages for storing and retrieving data. So, unlike the file system where you would have to write a new program and then every time you have to write another program to access another thing or another format. With database systems, okay, we have specifically designed a language that we all follow. Even if you don't use the same database management system, there's this structured way that we follow to either manipulate or retrieve data. Okay. Now, database language is similar to any programming language. It's a set of statements used to define and manipulate a database. Now, the languages can be classified into two. We have the data definition language. So it is not date, but data. Okay, let me make this one red so that I can review it later. So we have data definition language and then data manipulate languages. You see, these ones are two. Like these are two. Even when you look at the names, they are two. Now the figure below shows detailed classification of the database languages. So we have the first one, data definition, and then we have the second one as data manipulation. And under data manipulation, we have the procedural and then the non-procedural, which we are going to talk about. So in the data definition language, DDL, now this language is used to define the structure or the schema of a database. The schema is implemented at the physical, logical, and view levels. It also defines the mapping between the logical and the physical schema. So the data definition language have special types. The first one is storage definition language, which is used to define the storage structure and access methods or path which should be used by the database system. So under the data definition, we first of all set our storage definition language, which is going to tell us which is going to show us how we are supposed to retrieve our data from the hard drives, at which path is it supposed to go to before it gets to whoever is intended to go to, or to and fro. When someone is adding to the database, the process is supposed to go through. So in other words, the storage definition language is used to define the implementation details of the physical database schema. Now, data definition language and then storage definition language statements alter the structure of the whole database. That is, every change is saved permanently. So if you type create database me, that particular change that you've done is saved permanently. If you delete it, you have deleted everything from the storage device, and then there's nothing else that you can do about it. So the following are some common statements used in data definition to define database schemas. First of all, we have create. So you can use this statement to construct a relation or create a table in a database. So we say create table teacher. That one will create a table teacher, and then now you have to input maybe the table name, the attributes to it. And then we also have alter. Now this statement modifies the structure of the relation, such as removing, adding, or modifying attribute columns. Now we are not talking about the data in the system. Let me show you an example here. We are not talking about after John engineer. No, we are talking about the whole row here. So when you alter something here, it changes the whole row or whatever that is supposed to. So if you change the name, it will change the name. So next time, if you want to reference it, you are not going to see, you wouldn't be able to see MPID, but something else that you change it to. So everything that you do here is saved permanently. So first of all, the creates the whole table. Okay, the alter is used to alter maybe some few attributes that you have to the attributes. So let's say MPID, and then at first you used to take numbers, but now you have seen that the system has become crowded and you want to change it. So you want to change it from integers to maybe to take characters. I don't know if it's making sense right now, but we'll talk about it later. So that one is used to alter the columns. So that is for the data definition. The changes that you do here is stuck permanently. And then we have rename. So the statement renames a relation in the database. We have drop. Now drop, this statement is used to delete a relation in the database or an entire database. So I remember someone posted, I think 5 years ago on then times it was called Twitter, on Twitter, that he got a job at a company. And then they said they were testing him, so he should just, work around and play with the database so that he can understand their database and how it is like. So he thought the data that he was working with was just a dummy data and not real life company data. So he just went to drop the database. Now, when you drop database, it means that you've deleted the entire database. So this guy, when he was given an employment, he said they are testing him. on his probation day, he went to drop a company's database and every record that they have. Do you guys understand what the guy has done? Only to be asked why he did that. He said what the database he gave you tell you was just for play. How can a company give you data you think is for play? So yeah, as we said, the things you do here is stuck forever. So if you are a database administrator, and I know plenty of people will become database administrators, if you are, you don't drop tables like that. Okay. And then there's also truncate. So this statement deletes all entries from a relations, and then the relation structure is kept unchanged in the database. So the drop, let's say if you drop a table, okay, if you drop MPID, it means you are dropping the whole column here. If you drop the whole table, it means you are dropping everything here. But then if you truncate, it means that you are trying to delete the records in some of the in the tuples here. Okay. All right, does it make sense? So you truncate, you don't drop, you go and drop one healthy asset. Meanwhile, so this guy who said he's a senior database engineer. So I've been and then he just fell for this so it can happen to you, it can happen to anybody. All right, now let's talk about consistency constraints. Now, consistency constraints are the requirements data values must satisfy before being saved in the database. Now, sometimes this word seems big, but let me break it down. You see, there are sometimes some forms that you are failing. Let's say your age, right? Now, your age, you can't go and write 23 in characters, like in text form. You have to write it as a number. So we use this type of constraint to check whether what you are typing in is the correct one or not. Okay, so if a particular row is receiving integer, you don't go and type something else. So just like this example, this table that we have here, salary, it can't have any text value, like any character value like A or B or C or question mark. It's always supposed to be numbers. And then MPID, you see now this one has some form of numbers and characters in it. Okay, so we use these type of consistency constraints to check whether the data we are receiving is the correct data, and so on and so forth. Okay, so that is basically what we were trying to talk about. Now it says that you can see that all the values in salary, department ID, and project ID columns are integers, that's numbers. Now, when creating a new employee record, the salary value must be an integer to satisfy the integer constraints on the salary column. The database system checks these constraints every time an employee record is created or updated. And the consistency constraints for data values are specified using the data definition language statements. So that one to use data definition language statements for it. Okay. So there are some instances where some columns can't be left empty or null. Okay. In some way, when you are filling a form, they say required. It means that particular place, you can never skip it. Like when you are filling a bank form and then you get to Ghana card and you want to you don't want to fill it. It means you can't have your bank account because that becomes a requirement. You get it? Or you want to create a bank account and you don't want to put your name there. These ones are always required for you to use. And then we use the data definition language statements here when we are writing languages for the system, so that next time if someone inputs something, we can check. Now below are some common constraints specified by the data definition language. The first one is domain constraint. So when an attribute is defined in a database, its domain must be specified. Now the domain of an attribute serves as a constraint on the values that the attribute can take. This one, the domain is like more or less like general knowledge or like common sense. You know that in a form we are taking, let's say there's a form and someone is supposed to fill, right? We are taking employee, let's say employee ID is assigned by the system, so employee name, and then you go and put something else there. So the domain itself, the emp name, stating that, okay, so we are taking employee name, we'll let you know that, okay, so we want the name of the employee, not any other thing. So that becomes a domain constraint, a general knowledge constraint. This one, if you see it, you know that that's what we want. Job name, we want the job the person is doing, or the job title. That becomes the domain. Salary, this one we know that when we are talking about salary, we are talking about amount of money someone receives. So general knowledge, when you see what the attributes is, you will know what is taking. Mobile number, you can't see mobile number and go and type your home address there. Please, I hope you guys get it. So the first point as the domain constraints is just talking about the general knowledge of the attributes that we are trying to talk about. So if it is employee name, we are setting a constraint that we just need employee name and it's supposed to be in text or characters or letters. If we are taking age, you know that age is numbers. So that one is a domain constraint is that we are just taking age of something or a human or a cat or an animal or anything. Okay. So that is that. So when you see what is looking for, then you can put in the required data there. And then we have referential integrity. So in certain cases, we want the value of a given set of attributes in one relation to also appear for the same set of attributes in another relation. So this one, let's say we have the mobile money system like this, right? And then we need to check whether the transaction went through or not. You can see that the transaction ID should appear in my table the same way it should also appear in the vendor's table. Okay, so with the mobile money vendor, his table is supposed to have the same columns or the same attribute as me. So the transaction ID at his side and then the transaction ID at my side should collide so that we can know that, okay, so the transaction occurred between these two people. And then that is that. So we use referential integrity to also be able to set constraints, because one record of yours would have to appear in mine so that we can both create a relation out of it. All right. So we have an example. So we have a record of an employee and his project ID is mentioned in the record. Now we must have that project ID in the project relation. So this one is just for an example. So this whole one here, okay, is for the employee. So the employee has an employee ID, employee name, and all these ones. But project ID is also here in the employee table. I am sure there's a project table somewhere that also has the project name, the number of workers that are supposed to work on the project ID and all that. Okay. So to reference what project I am working on, the project ID column should also be part of my table. Okay, so that we can use that to make reference and relations between the two tables that I work on this project. And then the project has a table that has its own attribute and things already. Guys, I've been preaching. Do you guys understand? If there's any question to you can ask me. I hope you guys understand what I'm talking about. All right, so to be able to know that you guys understand, one person from this class should try and explain the referential integrity for me. Yes, one person. We will be done very soon and then we will close. Yes. Anybody? Sammy? Mr. Samuel?
Yeah, boss.
Okay, you've been saved by Mr. Prince. Yes, Mr. Prince. Take us through Oh, you have a question?
Hello.
Yes, sir.
Hello.
Yeah, we can hear you.
All right. To my understanding,
Mm-hmm.
with the referential integrity, I want to take order, for instance, if you want to order something from Jumia or Alibaba,
Okay.
you, the customer, you order an item. The item should have an ID. So I'm sure that the Jumia or Alibaba also has the product ID. So that ID is supposed to reflect on you the order this thing, and then the same thing should be reflecting on their what, on their database, so that it will be the same, and they will use it as a confirmation to be sure that you've ordered that item from that company.
Right. Yes, any other?
Okay, sir.
Mm-hmm.
The referential integrity in a database, there is an ID or an identification number that is assigned to a particular data. So on either end, you the customer and also the company, you, for instance, as my mother said, you want to order something from an e-commerce website. So the order number, you have, let's say, the order number to be 1. The company is also having the order number to be 1. So in case of any complaint, they know the particular item you bought, and then if there's any issue to be resolved, they use the order number to lodge the complaint for you and work on it, or any other process which has to be taken, that they use the ID. So the ID is usually like, it's kind of a reference to the transaction that you are making. So
Right.
that's my understanding.
Right. Any other person to add up to how they understand? Because okay, Frederick, your hand is up.
Okay, so please, to me, when we talk about the referential integrity, for example, let's assume that we have a database for a school, and
Okay.
in that database, we will have a table for students and then a table for subjects. And
Okay.
each student is also allocated to a class. So in that class, we must have a column that is related to a student. So in this case, let's say if I want to delete a class in the database and this class is linked to a student, because the students are referenced to a class table, it might be impossible. So the referential integrity is there to prevent a way that we cannot delete or drop any table that will make the database disorganized.
Okay. Yes, any other person? Dennis.
Yeah, sure. With the referential integrity, we're talking about that's my view.
Okay.
Referential integrity is talking about we know that the table that we have empire ID, empire name, job name, salary, mobile number, uh, department ID, and project ID. For
Yeah.
instance, the consistency of all these, how they relate with each other, so as to not to how they relate these tables, how they relate, columns relate with each other. I think that is for me. That's what I thought that it's talking about. How they they refer to each other, and how they relate. Their consistency in executing the whatever that requires of each column. I think for me, that's what I think is the referential integrity is talking about.
Oh, okay. All right, let's continue then. So another constraint is assertion constraints. And then it says that there is a constraint or condition that the database must always satisfy. So we must satisfy referential integrity constraints and then domain constraints. And if we understand that referential integrity constraints is when you are referencing different tables in a table. So when a changes happens or when you perform any changes, you're supposed to update other tables as well to be able to now satisfy that everything works perfectly for the whole thing to go on and save. The last one is assertion. That is that we have to make sure that referential integrity constraint is checked, and then the domain constraint is also checked. So if you are taking integers, integers are the ones you are taking. Else, there should be an error message popping up that, okay, so this particular field doesn't take text or doesn't take numbers, but rather some other thing else. Okay. Now, nevertheless, there are several constraints that we cannot express by using only these special forms. For example, the salary of every employee must not be less than 0. Okay. The employee must have a department and a mobile number. So the employee must have a department and a mobile number, and then those ones can never be now. So no, there shouldn't be an employee that doesn't have any department. It means that they are trying to be like Ghana government records. Yes, the Controller Accountant General's office. There are some ghost names. There are some people that are getting paid, but we don't even know the department they belong to. So can we say that there's an issue on the database because this country? All right. So the salary of every employee must not be less than 0. The employee must have a department. The employee must have a department and then a mobile number, and that one too can never be now. And this can be an assertion constraint on an employee relation. If the assertion is violated, then any modification to the database is rejected. Okay. So not only that we have to check the referential integrity to check whether the other side of the table is being updated, or the domain, what are we taking? We are not only supposed to take that one, but also think about other constraints that we can also set as part of the assertion constraints. So first off, we would have to set some values not to be now. Okay. So that if the place is left empty, we can't save it to the database. You have to set some part to be required so that we can always have to accept it when a person is filling the form. And then there are some IDs that has to also auto increment as we add new person on board. These ones are all the things we need to check as part of the constraints and as part of the assertion constraints as well. Yes, someone's hand was up. I think it was Prince. Prince, was it you or was Dennis? Dennis, yeah.
Yeah. I wanted to. You made reference to controller and accountant general, and I wanted to know why that, why those, because from what you are saying, the assessing constraint the others. It means that when you talk about, we have some sort of per the explanations that is given, goes with some sort of data integrity and some sort of security here. How come that people still bypass this system and then they enter into the controller accountant general department listen for ghost names to happen?
Yeah, so with the ghost names, no field is left empty. Just that the offices are empty. I don't know if it makes sense. You have all your details. They will give you the job title. So let's take like maybe a hospital like this. They will give you a job title. They will give you everything. Just that you don't work. You are just at the house, or you might be on 2 systems at a time. Maybe your name would appear at the northern region. So you'll be taking money from northern region as well as taking money from maybe Cape Coast here. You get it? Yeah.
Okay. Understood, sir.
Okay, sir. So we have authorization. So in a database system, some users can be allowed to perform certain operations based on the type of access they have. Now you see, this one I'm going to leave it to you guys to explain because this one is simple. So someone should just explain something. This one is simple. I mean, I can even bypass the move on, but I want us to have a conversational discussions and all that. So authorization, you guys should read through and then you give me what you think about it. Some people have not said anything. Magic has said something. Mr. Joseph, Mr. Joe, please are you with us?
Yes, I'm with you.
Yeah. So take us through the authorization as part of the constraint consistency.
Authorization. That is, if you want to access your database, there should be a format you have to follow to be able to access that data. That's what I understand about authorization.
All right, do you guys agree with him?
That's, you have to
Do you guys agree with him? Friends.
Sir.
Yeah,
Yeah, Prince.
Hello.
Agree with him.
Yes. Okay, to my understanding about the authorization, people in the various organizations have rules. So with the authorization, if you are an administrator, you have some certain rules that you can do that other people cannot do.
Okay.
And such examples are the read authorization, the insert authorization, and the update. You, the system administrator, they've given you that privilege to the system that you can perform those one, not anyone that can do that.
Okay. Yes, any other person? Etonam, you want to hear your voice again, oh, please. Oh, madam is not here.
So I'm here.
Oh, okay.
So the authorization is like everyone is given a specific task or maybe a specific area to access. So from what I read, an accountant can only have access to the payroll because that's what he's doing.
Okay.
And the administrator can also have access to a specific area. So it's specified kind of. Yeah.
Yeah. All right. Any other person? Any other person? Think someone. Hey, we have a lot of people here. Okay, so let's take Al Hassan.
Yes, sir. Actually, with the authorization, I will talk about, I will use PV, PV, a validation PV as an example. Okay. You see, validators have the right or they have the authority to certain parts of that PV. They have access to that. They cannot do anything. The data controller and accountant general have been giving them some kind of restrictions to do on the PV for validators. I don't know whether you are getting me.
Oh, I get you.
Good. So validators can only have the authority to do certain parts of validation, or they can do certain things on the PV, but not everything they can do.
Yeah.
Yeah, this is what I can give as an example.
Okay. I think there were still people. So let's take Frederick. After Frederick, then we come to Mr. Dennis.
Okay, please. To me, how I understand the authorization is, you are given access to a particular data based on the role that you are performing or the role that you have in the database, just like what Ethanam said. For example, when you take UCC database, for example, all students have access to only their results. So if they did not restrict us to only view or read our results, and we had access to the portion like we changing our grades and the rest. And then in order to protect the data and also improve the data integrity.
Yeah.
So that is how I understand the authorization.
All right, Mr. Dennis.
Yes, sir. The job that you have been assigned, that's where you are given a specific work to do. So that's what's assigned to you. That job that you do. And then the way they have assigned you, that gives you that the permission that they give you to do that job that you have been assigned to do. So the permission synchronizing with the specific job area that you are operating in. Thank you, sir.
Okay, Hassan, I'll take you and then that'll be all.
All right. I think I cite with one of my colleagues who used the portal, the student portal, as an example. I think I cite with him, and then I saw one type of authorization, which is insertion. Here, if you look at the student portal, we can only insert our passwords or change our passwords and the rest. I hope you are getting.
Oh yeah, I get it. So sometimes
Hello.
Yeah, we get it. Can you hear me?
Okay, that means we have been given the authority to do this kind of insertion.
Yeah. All right. So it says that a user may be assigned to all or none or combination of the various types. So in our case with the UCC portal, we are assigned to combination of some of them. So there are portions that we can edit and there are portions that we can't do anything about it. So when you open your portal like this, you can obviously change your name and no, you can't change your name, but you can change some few details about you. I think they give chance for you to add your location, your number, and all those ones. And then if you are a regular student too, it would give you chance to even select the room number that you want to be in. That's the 100. So yeah, and then there are some things that they would give you the chance to update, but there are ones that you can't do anything about. You can only view it and that's all. And even the people that work on the database system, some of them don't have these kind of authorization as well. Okay, so maybe someone can be a database manager working on UCC system, but cannot have access to change students' records because that particular authorization hasn't been given to that person. All right, so that is how it is.
Yeah,
and I think
thank
few
you
people
very
that
much.
I think have access to that one. Then we move on to data manipulation languages. So we are done with data definition language. We are going to talk about data manipulation. So they said there is a special set of statements or commands that allow users to access and manipulate the data in the database. And these commands are used to perform operations such as adding, inserting, updating, and retrieving data from the database. Okay. Now there are two. These ones are different. The first one is to create the structure and the schema itself, and then the next one is to modify the data itself, like to modify the actual records that is in the database. Okay. So we have two types of data manipulation language. We have the procedural or non-declarative. And these are considered to be low-level languages because it requires the user to define what data is needed and how to get the data. The procedurals are often called one-at-a-time data manipulation languages, or DMLs, as it retrieves and processes each record separately. Since it's a low-level language, it is generally harder to learn. And then we have the non-procedural or the declarative. So these ones are considered high-level languages, require the user to precisely specify or declare, as the name implies, what data is needed without specifying how to get the data. They are also called set a time. The other one is one at a time. This one is set a time. So that's non-procedural DMLs can retrieve several records using a single command. Nevertheless, since a user does not have to specify how to get the data, the database system has to figure out an efficient means of accessing data. So being a high-level language, it is easier to learn and use than the procedural ones. So some of the examples are the insert, the select, the update, the delete and merge. So the insert is used to add new data to the table. So this one is adding a new data. The select is used to retrieve. So you remember I was saying something like select from maybe username. So when you log in, when you log into your portal, the select from your username and then your index number is used to retrieve the information, your information from the database. I don't know if it makes sense. Does it make sense, guys?
Yes,
Hello.
yes.
Hello.
Yes, it's making sense.
All right. So we also have the update. So that one is used to modify an existing data in the table. So in your case, update data, then. Okay. So that is how it is. I have some Java code. You can send me the check, but after I'm a bit intelligent and the check. Yes. Let me see if I can turn on example and show you guys something. Yo, more class. Hey. Have a class. I'm trying to show you guys something, so you guys should give me like in a few minutes. Hello. Can you guys hear me?
Sir. Yes, please.
Yes. These are some databases that we. Okay. Let me see the query. Okay, so if I want to select, so you see this code here. You guys see it?
Sir.
Yeah, so if I want to retrieve something, okay, it is select. And then the select style is select all from repair. That is that's the table repair in SG shop. Is the table repair is part of the SG shop database. Okay, so this is a table called repair. And then we have a table called users. Okay, so these are two different tables. And if I want to select something from repair, or I want to retrieve an information from repair, I'll do select from repair where then a particular value in the repair table. And I'll just select it. So those are the codes I was talking about. I wanted to show you guys like a full query. I can't get the book. Give me a few seconds. I'm coming. Let's see. I had a code here, so I just copied it inside. So, all right. Can you guys see? Hello.
Yes, sir.
Okay, so
Yeah,
create.
this is.
So
You
yeah,
can see.
this is how this SJ shop here was created. So I did some projects for some guy, and then he needed to create like a repair shop system, where when you come in, you type in your it's like a repair shop. So you type in the problem of the problem you are facing, it will bill you. You can pay at that moment, or you can wait a little while longer and then pay later. So with the SJ shop, this is the main database here. So create schema SJ shop is what creates the whole database. And now use SJ shop means that you want to use the database now. Now create table repair is going to create the repair table for you. And then the repair number is going to be like a column. So let me open the repair table for you to see. All right, so that's what you see here. So the repair number is this one, and then that will be our primary key. That will be our key. So referential keys, that the referential something that we are talking about here. We will get to the main details later, but I just want to show you something. So this code that you see here, okay, is the data definition code. So this one defines the whole database and what you want to take. Okay. So with the repair number becoming your column name or your attributes, and then these are the constraints that we were talking about. So this one, the only constraint is that it's supposed to be auto increment. So anytime someone comes in, the repair number increases. And then we have a customer name. And then the customer name is a domain constraint. So we know that we are taking a particular, we are taking name for the customer. And then we are using voucher, which will come there later. But then that one too is setting the constraint that we are taking text alone. And then we have phone number. Phone number too, we are taking text. But then when we come to price, you can see that we have changed from voucher to decimal. Okay. So now it is decimal. And then we are setting it not to now, which means that that particular place, then we have to take our money at all costs. And then how much the person is willing to pay initially. And then we just move on and on and on and on like that. And then if we want to insert something into the table, so you see, when you start creating your database and you are done, you have to insert some values into it so that you know that, okay, so the table works well or the whole database works well. So this is the data manipulation language. So insert into repair. So now we are inserting whatever we want to insert into the repair table, which is this one here. And now these are the sequence you want to perform the insertion. So repair number, so we add a value to it. Customer name, John Doe. Phone number, 123456789. Model, the phone is iPhone 12. Let me push this one here. And then the serial number of the phone or the SN is this one. The problem is screen cracked. The price is 100 cedis, and then they paid 50 cedis right now, and they are setting the whole thing to active, meaning that we are working on it. Once you come and you take and you pay, then you set this site to closed. So that is how the project is. But you see, you have to create a database to store this simple information. And then this is the whole thing that we just did. So this is just for one data, like one particular record. The one tuple is this one here. Please, does it make sense? Or I'm confusing you guys?
No, it's making sense.
All right. So these are the things you'll be doing this semester. So I want you guys to download this is XAMPP. Download XAMPP and install it. We'll be using XAMPP throughout the course for our practical session. So if I want to delete something, you see there's a drop button here. If you drop it, it means you are dropping everything. Any additions or subtraction?
Yeah, sir. You said we should download something.
Yeah, download XAMPP. XAMMP. Let me text you guys in the chat.
Okay.
Yes, any more questions? Oh, the language that you guys saw, okay, is MySQL. That is my SQL language or my SQL queries. So that is how it is. It's intertwined with the database, with the project that you've created. So you need to understand a little bit of programming. Any question? Yeah, someone's hand is up.
Yeah,
Joseph.
someone's hand is up.
Yes, sir. The practicals, how is it going to be? Is it going to be like what we've been doing previously, or it's going to be an intensive practical?
Oh, not really intensive, but something that
not really intense, but something that
I hope it makes sense.
I hope it makes sense.
So I didn't hear you. The line was breaking.
Hello.
Sir.
I am saying that it's not going to be anything
I'm saying that
intense,
it's not going to be anything intense,
but
Okay.
you'll
but
be able to
you
write some
you'll
query
be able
language.
to write a query language.
Okay. Thank you, sir.
You're welcome, please.
You're welcome.
All right, guys. So this is where I would leave you guys. We'll meet again next week. They said next week is face to face, so y'all will see me. Have a wonderful weekend. Bye.
Same to you, sir. Bye bye.
Master, please, have we closed?
Hey, Ahmed, what's up?
Yeah, Kuro.
Now what you go on?
Oh, Maza, I mean, I dey look you. I dey look you.
You know,
Look you. You dey finish your project.
Please, have we closed?
Yeah, it's close.
Okay, thank you very much. Master, this topic here, it seems we have lectures here, Ahmed. Where some lectures on our chairman, because maybe I said, what's the lecture?
Ah, Mr. Boss Papa. But the man of a phone was oh boy.
I don't know what they are trying because me wish.
The man of a phone was and getting sa. You won't hear, my son and me, yes, sir. Said I be a Muslim as my baby. Mr. Dan. Mr. Daniel. Mr.
Yeah,
Daniel.
hello.
Oh, sorry, me so call fetch me pa.
Oh, okay. We can't complain.
Me so call na me hu na asi asan ba. Lectures yakọ bake ni asan return into the month na.
Hey, as it were more record into stop Hawaii.
Oh, me